Today is already the 12th episode of Programming Problems, and today we will dive right back into advent of Code 2015 titled Probably a Fire Hazard. For today's problem, we'll deal with our neighbors who keep defeating us in the holiday house decorating contest every year. So, naturally, this year we will take it to the next level and deploy 1,000,000 lights in a 1,000 by 1,000 grid. Santa has mailed instructions on how to display the ideal lighting configuration. The instructions are of the following form, where there is a command followed by 2 pairs of 2D coordinates. The command can be any to turn on or turn off the lights or to toggle them. Note that the positions which we get in the grid are the rows and columns, which are numbered from 0 to 999. Now, if we follow all of Santa's instructions, how many lights are lit? Let's look at some examples. For the first example, we have the instruction to turn on every light in the grid. See how both the very first index, 0, 0, and the last index are included in the range? The second example toggles the state of all the lights in the first row of the grid and no others. So if a light was already on, it would turn off and vice versa. Now for the last example, we'll turn off the 4 lights that are dead center in the grid. Hopefully by now we've already managed to illuminate some possible solutions for this problem in your mind. Please feel free to pause the video and give it a shot. When you're ready, we'll continue with looking at the solution. A 1,000 by 1,000 grid is typically suitable for an n-squared algorithm if the number of operations is small enough. In this case, there seem to be about 300 instructions, which means that, in the case where every instruction touches the full grid, we would do 300 times 1,000 iterations where we can do something. Since we're not on a strict timer, we can consider this fast enough to just track the lights in a grid containing 1,000,000 lights. Here you will see Python code which highlights a high-level approach for solving this part of today's problem. First, a grid is created. Then, suppose we have a getInstructions function which returns the instructions as a triplet of a command and 2 coordinates. Then we can simply do an if-else construction to either turn the lights to a specific state or to toggle them. At the end, all that's left to do is to go over each row and sum all the values in the columns. Once we have that, we simply sum all the rows and we print the output. Now, we have the turn and toggle functions, and they can be quite simple. Suppose that a corner is a tuple with x and y positions, then the turn function only needs 2 nested loops, one for the rows, then one for the columns within the row. Then per row-column pair, we just set the state, which can be a Boolean value. The toggle function is quite the same, but toggling a value just means that you set the value of a grid position to be not, or the inverse, of that same grid position. Now, one final implementation detail here perhaps is that the range function loops up to the second value that was passed. So if we iterate from the range of 0 to 10, then the last iteration would be at 9. Hence, the value from corner 2 needs to be incremented by 1. And that's it already. One more star in the bag. Let's continue with part 2. It turns out that we made a mistake and we mistranslated Santa's message from ancient Nordic Elvish. What was meant was that every light in the grid actually has individual brightness controls instead of simply an on and off state. This means that each light can have a brightness of 0 or more. The commands then mean the following, where turn on increases by 1, turn off decreases by 1, and toggling increases brightness by 2. Assuming that all lights start at 0, what is the total brightness of all the lights combined after following Santa's instructions? Again, I have a couple of examples for you. In this first example, we turn on the very first grid cell. Assuming that this was the first command in the list of instructions, then the brightness of the cell, and thereby the entire grid, would increase by 1. The second example touches all cells and toggles the brightness, which means that every light gets 2 additional brightness. Given that there are 1,000,000 grid cells, the total brightness increases by a whopping 2,000,000 in one instruction. At this point, again, take some time to do part 2 if you haven't already. Depending on how you coded part 1, it is perhaps not that hard to modify your solution now. As was maybe clear to you, the solution is very much the same as for part 1. It is just that the meaning of turning and toggling have changed a bit. Note that for turning on, where the state is equal to true, we still just increment by 1. However, for decreasing the brightness, we need to consider that there is a lower bound on the brightness of the lights. They can never go below 0. For toggling, the algorithm remains trivial, and we just change it to incrementing by 2 instead of negating using the logical NOT operation. And that's it again, 2 stars covered. Thank you so much if you are following along, and I hope you learned something today. Please have a look at the channel for solutions of other days, and I hope you look forward to me posting new solutions as time goes along.